Okay, this video is about exercise 6C, further symmetry properties, and then we're going to have a look at Pythagorean identities. So, as always, you can read this part yourself and always look in your textbook, of course, for for examples that we don't do, because ours will be different to yours. All right, so the relationships that you are given are quite standard. So we have pi on 2 minus theta for sine and cos, and we have pi on 2 plus theta for sine and cos. But we have to be careful because we're not always given the pi on 2 option, of course. All right, so if we have a look at the first one, we've got sine of pi on 2 plus theta. And if you look up here, you can see that that is equal to cos theta, which is fine. That seems nice and easy. Now, if you go back into the question, you're going to look for cos theta. As you can see here, though, cos theta is not given. All right, it is not going to always be the same as what is given here, which is a different angle. This is not cos theta. So sometimes you have to do a little bit of work first. So I would suggest ruling up what you know. So let's have a look first at the sine information we know, okay? So we have that sine theta is equal to 0.1. So that's the information that is given in the question. So let's just draw that up quickly. What is that going to look like? So if we draw the unit circle, I'm actually going to put, sorry, can't see. I'm actually going to put the circle to show you that that, of course, means 1 and 1 here. So what is this going to look like? If we know that sine theta is equal to 0.1, sine is our y-axis. So 0.1 is going to be right down here. So it means that there's the value for sine theta. So it's going to touch the circle about here. So it's actually a very small angle. Okay, and therefore we know that this is going to be 0.1. We put our right angle in there. And the easiest way to do these questions is to then, we know this is 1 because it's the radius. We have a right angle triangle there. So we're going to do Pythagoras, and I've done that for you. You can check it. But if you do Pythagoras, you'll get 0.99 actually. I'm just going to put 0.9 in there. All right, so we have sine theta equals 0.1. So we're just going to work out what cos theta is as well. So cos is obviously adjacent over hypotenuse. So in this case, there's our theta. Adjacent is going to be 0.9 divided by our hypotenuse. So cos theta in this case is also equal to 0.9. I say also because this is what we're given for cos of the other angle being 0.9. Now, let's skip across and do the cos one as well, because yes, it's going to come up. All right, that's 2 seconds work, but then it'll help you do the questions from then on in. So we've got cos of this angle is equal to 0.9. And yes, you're right, we've already done the work because it is the same. Okay, I'm doing this because it won't always be the same. So if there's our unit circle, and we know in this case, we're given cos, which is an x value, or along the x-axis, and 0.9. So if this is 1, we're looking at about there. Okay, so again, you'll see it does draw the same sort of triangle because it's going to hit up there with this angle being the one that's in there. Now, we've already worked out this is 0.1, okay, because it comes across from here. Oh, that doesn't look like 0.1, but you know what I mean. And we know that this we're going to use as 0.9. So cos of this angle is 0.9. So therefore, we're going back the other way. Sine is opposite over hypotenuse. So here we are. So sine of this angle is in fact opposite over hypotenuse, which is 1. So it's 0.1. So you could fluke it in this way because they are the same values, but it is something that you need to be careful with. Okay, so now we did put that it was worth for cos theta, and we worked out down here that cos theta is in fact 0.9. Okay, so our answer to that question is going to be 0.9. Okay, we can use the relationship again to do the next one. So sine pi on 2 minus theta is our first one up here, and that is going to be equal to cos theta. And obviously that's the same as well, okay? And we just worked it out. So cos theta is equal to 0.9. Sorry, I'm mucking up my screen a bit here. Okay, next one, let's have a look at what we've got. If you look up in the complementary relationships, you should see straight above that this is going to equal sine theta. So we want to go down to what have we got sine theta? No, we have sine theta. That's in our question. So that one's easy to do. It's in our question. It's already given to us. Okay, cos of pi on 2 plus this angle, okay, is going to be equal to, from up here, negative sine of the same angle. So straight away we put down our negative, and if we look down here to the work that you've already done, the answer is going to be 0.1. All right, so there's the first 4 on your page. Okay, making sure that you're checking the angle type, okay, the name of the angle, because it might be different. All right, if we go a little bit further here, so now we are in a different quadrant to what the complementary relationships have given to us. So let's have a look and see where we are. So if we want to do 3 pi on 2 plus theta, it's going to be, because this is 3 pi on 2, it's going to be in our 4th quadrant somewhere. Don't forget, we already have the information that this needs to be 0.1, and across is going to go out far. This is going to be 0.9. And if we think about what the angle looks like, it's going all the way around. So it's going 3 pi on 2 plus theta. Okay, so we want to know what is coming out. So we draw our line there, thus creating our triangle that way. All right, so we have 0.1, we have 0.9, and we have our right angle triangle. And of course, this one is equal to 1. All right, so we want the sine of that value, and sine is opposite over hypotenuse. And in this case, we're remembering that the angle we want is in here. All right, the last part of the pink is what we want. So the opposite angle of that is 0.9, and of course it's going to be over 1 because that is the hypotenuse. Also, we need to remember we're in the 4th quadrant. All stops to city. Oh, that's how I learn, and that's how I remember it. C is positive, which means sine is going to be negative. So your answer is negative 0.9. Let's do this one the same way. So if you draw up your rough drawing of the unit circle, this time where are we going? 3 pi minus 2, which we know is down here, but this time we are going to take away an angle. Okay, and think about again. So this is the x value. So this one has to be the long one. This is up here. So it's going to be, I'm sorry, I've drawn it so small. It's going to look like this. So this is 0.9. This is 0.1. This is a right angle here. And if we think about what we want, okay, or where we want it, we can go from there. So we're in the 3rd quadrant too, so we want to think about that as well. So cos SOHCAHTOA is adjacent over hypotenuse. Okay, and this time we've got the angle, so we want to go adjacent. Let's have a look. All stops 2, so this is going to be a negative value, and we have adjacent is going to be our 0.1, and of course our hypotenuse is 1. So the answer to this one is negative 0.1. Excellent. That is the first part of 6C. Now, let's do the next one. Next one we're looking at, so your next page is the Pythagorean identity. So what we basically get is a formula. You can have a look at this or have a look in Education Perfect. If you look up the Pythagorean identity, look up your textbook, or you could YouTube it very easily if you want to know how you get there. But basically, we need to remember this. So cos squared theta plus sine squared theta is going to equal 1. So the first thing you want to do is just put those values in. So our formula is 1 equals cos squared theta plus sine squared theta. 1 equals, so in this case we have cos squared theta, or we have x, that's okay. So we're going to go 3/5 squared, but we don't have sine squared theta. Okay, so we can't deal with that yet, but we can certainly play around with these numbers. Now on here we're going to get 9/25 plus sine squared theta, and if we make that 25ths, then it makes life a lot easier. All right, from there I'm going to subtract 9/25 from both sides. So we're going to go 25/25 minus 9/25, and then we get sine squared theta is equal to 16/25, resulting in sine, I should have used x, sorry everybody. Sine of x is equal to plus or minus 4/5. Now, hopefully you're thinking ahead. How are we going to realise if it's a plus or a minus? And we need to, as we have been doing, look back and see whereabouts this is happening. All right, so 3 pi on 2, between 3 pi on 2 and 2 pi is going to sit us in the fourth quadrant. And we know that in the fourth quadrant, sine is negative. So you're actually going to use sine of x is equal to -4/5. Okay, or you could just obviously get rid of the plus in your answer there. All right, excellent. So now that we have cos squared theta and sine squared theta, we can work out what tan squared theta is. Okay, why don't you take a, no, actually, yeah, try and see if you can get ahead of me. Okay, so I'm not going to talk. Work out, knowing that tan of x is the same as sine of x over cos of x, go ahead and find tan of x for me. And look up when you're done. Terrible pencil, sorry. Okay, hopefully you got tan of x is -4/3, and we know that tan is negative in that quadrant, so we're also happy with the fact that it's a negative. Okay, let's do one more. All right, so we're going to go straight into our identity. So 1 is equal to cos squared x plus, this time we have sine, so plus 5/13 squared. Please go ahead. Pretty much exactly the same. Okay, hopefully you got plus or minus 12/13. Then if you have a look in the quadrants, you should see that it is in the second quadrant. where cos is negative. So your answer is going to be negative 12 over 13. Okay, have a go at tan and look up in a minute. Okay, hopefully you got negative 5 over 12. And that, my friends, is 6C. Questions are on the bottom of your sheet. Good luck.